All right, folks, let's get started. So, welcome to the Sedona Community Office Hour of February. And today, as usual, so we're gonna go through uh the release we had in December last year, and we're also gonna talk about uh what is upcoming to the next Sedona in the next Sedona release. And after that, so we have another Sedona PMC member, Pavel, is also here. So he's gonna give a introduction and a presentation about the geo package data frame reader they implemented like in the last release, and he has some very cool demos to show. Cool. So first of all, so if this is your first time joining the office hour, so Sedona is an open source cluster computing engine for processing geospatial data at scale. So Sedona has our website, so sedona.apache.org, and our GitHub repository is under the Apache Server Foundation. We also have our Twitter account. We also have a LinkedIn account recently. So please be sure to follow our account on social media to get the latest news. And the status of Sedona. So as you see on your right-hand side, so many companies are using Sedona in production. And the Sedona is a project we started in 2015. It became mature in 2017 and joined the Apache Software Foundation in 2020. It has over 10,000 corporate users. On GitHub, it has over 130 contributors, and it has 2,000 stars on GitHub right now, and it has over 2 million downloads last month. So lots of people using Sedona. And in total, the downloads of Sedona has exceeded 44 millions. So that places Sedona among the top 0.3% most downloaded package on PyPy. So if you haven't tried Sedona yet, please make sure to try it right now. And here is another graph that shows the community growth of Sedona in the past few years. So the chart on the left is showing the cumulative downloads of Sedona Python package, which was released in around 2020. As you see, we are observing a exponential growth curve, which is really exciting. And the chart on your right is a cumulative commits over the years, and that actually starts from 2015. So as you see here, we are also observing a like exponential growth, which is also great. So in the next few years, I believe we are going to continue growth like this. That's going to be really good. And a brief introduction about Sedona's system architecture. So the diagram on your right is a diagram that shows the entire ecosystem around Apache Sedona. So essentially, Sedona has three layers. So the first layer we call it spatial query processing layer, so which is the layer on top. So this layer provides programming interface to the external users. So that includes spatial SQL, Python, Scala, Java, and R. And it also integrates with a bunch of developer tools such as Zeppelin, Jupyter Notebook, GeoPandas, and RStudio. It also equips with a number of distributed query algorithms, so that can actually take your query workload and distribute that, scale that to a number of machines in the cluster. It also has a spatial query optimizer that can detect your spatial query and automatically figure out the best query plan for that query. The layer, the layer under spatial query processing layer is distributed spatial dataset layer. So this layer is providing fundamental data structures for Apache Sedona. So it has spatial data partitioning that actually partitions spatial data according to their spatial proximity. And also it has spatial indexing and data compression, good serializers, all stuff here to speed up the query processing. And Sedona also runs on top of a number of machines, distributed engines. So it supports Apache Spark, support Apache Flink for stream data processing. It also supports Snowflake. And there is a free app called Sedona Snow on Snowflake Marketplace. So if you are a Snowflake user, make sure you use it. So, but among all engine supports, our support on Apache Spark is the most comprehensive one. Cool. All right, let's move on. So the easiest way to get started with Sedona is always to use Sedona Docker. We have an official Sedona Docker repository on Docker Hub. So you just search Apache Sedona, you will find it. So it is a repository under the Apache Software Foundation. It is an official one. And you can easily pull the latest Sedona Docker image like this, Docker pull Apache Sedona, and you can provide a version number. And after that, you can easily run a Docker, you can easily start this Docker image by using this command. In particular, this will give you a Jupyter Hub give you a Jupyter Lab in web interface. So you will be able to open that in your browser, and you'll be able to play around with through the Python interface in Sedona. So Sedona usually follows this 3 months release cadence in the past releases. So for example, we made a release of Sedona 1.6 in May last year, 161 August last year, and 170 December last year. We will make a new release, I don't know, 171 very soon, later this month or early next month. So what's new in the last release, Sedona 1.7? So we released a couple exciting features in 1.7, and 1.7 is a major release, as you can see from its version number. So there are a couple exciting features. In particular, there's three of them. So the first one is the k-nearest neighbor join. So this is a new join query operator we introduced in the recent years. And another one is the GeoStats toolbox. It is a scalable spatial statistic toolbox that allows you to perform statistical analysis on data and give you a bunch of statistical significant index. Okay. So first of all, so what is KNN join? So let's take this one as an example. Suppose you have two tables. So the first table is restaurant. The second table is driver. So the restaurant table has the locations of all the restaurants. The driver table has locations of all the drivers. Now the question you want to ask is, so tell me the closest restaurant per driver. So this is a very typical k-nearest neighbor join query. And in Sedona, you can actually run this query in the following uh, spatial SQL query. As you see here, in the from clause, we put two tables there, restaurant and driver. And in the where clause, we have a new predicate called stknn. So this is a new spatial query predicate introduced in Sedona 170. And so this is not a regular predicate that is available in spatial SQL query. So this is a new predicate invented by ourselves. In particular, is to introduce this particular query, and our query optimizer will actually detect this particular query pattern and rewrite it to support the nearest neighbor join algorithm. So the formal definition of k-nearest neighbor join. So a k-nearest neighbor join involves two data sets. So what you want to do is that for each record in the first data set, it finds the k-nearest neighbors from the second data set based on a given distance metric. You already know how to do that using Sedona SQL. Another way to do that is you can use the explicitly join operator in the query, and you can use the stkn as the join condition. So in practice, there are many real use cases for k-nearest neighbor join. So for example, this the screenshot on the left is a screenshot I took from Redfin. It is like for example, you may want to see what are the nearest public school around my house, around each of the properties, right? So this is a very typical k-nearest neighbor join. Another use case for k-nearest neighbor join is the reverse geocoding, right? So basically, you have a bunch of a bunch of locations, a bunch of coordinates. You want to find the nearest address for each of the coordinate. So this requires a k-nearest neighbor join between the input coordinates and the address table, the coordinates of those address, right? So this is another example for the k-nearest neighbor join. Cool. Uh, GeoStats. So GeoStats, as I mentioned, is a scalable spatial analysis toolbox. In our office hour in December, so we have a Sedona contributor, James Willis, came into our office hour and talk about the GeoStats functions we had in the last release. And in last release, Sedona 170, in particular, we introduced three statistical functions. The first one DB scan clustering. So this is a highly anticipated feature. So many people in our community has been asking for the DB scan clustering. So in short, it is clustering spatial objects based on their spatial proximity. And so you can right now do that in Sedona through a explicit Python or Scala function called dbscan. So this code snippet shows that how to run this particular query. And the visualization on your right, so this one is a visualization of the dbScan cluster result. You have a bunch of I believe this was a data set of all the probably real estate properties in Florida. You can use the dbScan to cluster them and figure out the real estate clusters in Florida. And if you run that query on Sedona DataFrame, you're going to get a dbScan output. It will look like this, right? You're going to have for each object, you're going to get a cluster ID that tells you so what cluster it belongs to, and then you can do a group by ID. You can figure out object within each cluster. Another statistic function is called hotspot analysis. So it's to find statistical significant hotspot in your dataset. And in particular, it uses something called get_is_odd to quantify the output of this quantify the definition of hotspot. So that means this method is to, as I mentioned, to find statistically significant result, and also it tries to eliminate the impact of random errors in the datasets. And so this is actually also different from in the past, many people in the community has been using H2 or H3 to aggregate spatial object based on H3 ID or H2 ID, and you get some sort of uh, aggregation count per cell, which is great, which shows you some sort of hotness of the data set, right? But the problem of that approach is a simple aggregation. It is not statistically significant, and it cannot eliminate the impact of randomness errors. So the get_is_odd is the correct and the best hotspot analysis tools for that. The third statistic function we introduced in last release is the outlier factor, local outlier factor. So it is to find anonymous outlier data points by measuring the local deviation of a given data point with respect to its neighbors. So you can use this function called local outlier factor in Python to trigger this function. And the figure on your right is a visualization of the local outlier factors. In particular, you see a bunch of data points, and you see a bunch of data points and a bunch of red circles. The radius of that red circle is actually corresponding to the outlier scores, meaning that if the circle is large, that is a large outlier because it is not close to its neighbors. As you can see, it is pretty obvious from this figure. So points within these two clusters usually has a small red circles, but for object here, they usually have a large circles. Cool. So what's next for Sedona 171 release? So first of all, one very exciting feature is the GeoStats SQL interface. So the three GeoStats functions I mentioned, right now they only provide Python and Scala interface. So it cannot be called through SQL directly. But in the upcoming 171 release, we're gonna introduce SQL interface for all three functions. For example, you can do st_dbscan, st_local_outlier_factor, and st_getIsOrder. So it will automatically call the function behind the scene, and you can do that through pure SQL environment. It is super exciting. The PR of those SQL interface has been merged into Sedona GitHub repository, and in a few weeks you'll be able to enjoy those interfaces. Another really exciting feature we have, and this PR has been merged last week, is a stack reader. So, like if you deal with raster data in the past, you probably will know stack catalog is possibly one of the most widely adopted catalog infrastructure in the industry. Like Planetary Computer, LM84, they all host a stack endpoint that allows people to browse the raster assets they have on in their storage. So in Sedona, we introduced a new data source called Stack Reader that can actually explore any stack endpoint, and it will able to read all those stack dataset into a data frame, and also it will be able to read the geometry part into a geotype in this data frame. What does that mean? That means you'll be able to join those stack assets, stack atoms with other vector data source, with polygons, with other vector data you have. That is super exciting. And it will allow you also to save the result back to stack GeoParquet, right? So GeoParquet and stack GeoParquet are new standards emerge in the community, and you'll be able to save that into those two formats and exchange that with other people. This PR has been merged, and another exciting feature of this is so the stack data source reader also allows filter pushdown. So meaning that you don't have to. So this catalog could be huge, right? It could have hundreds of thousands of raster data, raster images. So we allow filter pushdown, meaning that you can give st contains predicate on data source, and Sedona will be able to push down this to the raster to a stack data source. It only fetch the data that intersect with the st contains predicate. You don't have to read the entire catalog into Sedona data frame. So another interesting feature, the third interesting feature we have in next release is a spatial partition data frame for GeoParquet files. So in the past in the past decade, Sedona has been there for a decade, right? So Sedona is known for having a really good spatial partition mechanism that can partition spatial data across machines, and it can yield very balanced partitions, which both preserve spatial proximity and also try to maintain load balance. So that turns out to be a really important feature, and that is really beneficial to GeoParquet files because the performance of GeoParquet files, in particular, the filter pushdown performance of GeoParquet file is is direct affected by the partitioning in the GeoParquet files. For example, how do you partition the row group? How do you partition each GeoParquet file in your datasets, right? Because that will affect the size of your bounding box in each GeoParquet file. So it is super important to make sure that your spatial partition in GeoParquet file both preserve spatial proximity and load balance. And this is something Sedona has been doing really well. In the next release, for request of the community users, we will introduce a spatial partition data frame for GeoParquet files, meaning that you can call a function that will partition a data frame based on the spatial proximity, and it will allow you to output that to a GeoParquet file. In the past, all the functions we mentioned here, so they are implicitly done, and they cannot be exported outside Sedona. This time, we decided to allow people to export it to external GeoParquet files. And that way, you'll be able to have way better balanced partition in GeoParquet. And you'll be able to use the KDB tree partitioning and the quad tree partitioning in Sedona core. Cool, that's upcoming release. So next, we're going to talk about the third interesting, exciting features in last Sedona release, DataFrame-based readers. So let's welcome Sedona PMC member, Pavel, to give us a cool introduction and the demos. Welcome, Pavel.
Hi, I hope you can hear me. Yes, I am Pavel. I'm a PMC member of Sedona. I started contributing to this project back in 2019. And right now, mostly I'm focused on writing a book about Apache Sedona. I think that's the introduction. Yeah, and let me maybe share the screen right now because I have few slides prepared for that, and also Jupyter Notebook demo with the geo package. And maybe regarding the release, I'm not sure if I will be able to do it before the 1.71 release, because I'm also working currently on some other features, which I will show on the last in the last slide. Yeah, so let me try to share the screen. So hopefully you can see it. Yeah, so
Yes.
I will try to be quick because I don't want to spend a lot of time on explaining GeoPackage, because we introduced recently the GeoPackage based reader, DataFrame reader. So GeoPackage is SQL-like container format, which for quite some time is in the Geo special community. It supports raster and vector data. So in one data format, you can have raster data and also geometry data. It keeps the information about the CRS. With the extensions, I think also it supports some indexing like R3, but it also gives the information about the B boxes for each geometry, and can store multiple raster and vector data. I mean, separate multiple features. For example, you can have rivers, so you can have buildings in just one GeoPackage file. And regarding the GeoPackage Sedona reader, so right now at the current state, we have a vector. We can read the vector data from the GeoPackage. We can also read the raster, but I think for now it's only PNG. I think and GeoTIFF. For other data formats, we don't have that yet implemented. We can read the metadata about the table. So when you get the GeoPackage file, you can look what's actually inside that file. We can also read a multiple GeoPackage at a time. So basically, if you have a GeoPackage with the same schema and you have multiple of them, you can load them easily from, for example, S3 bucket or GCS. You can read that from the cloud storage, so GCS, Azure Blob, or S3, but basically you can also load it from the local path and also from the HDFS. It works with on-premise Sedona, it works with Robots and Databricks, and it's a DataFrame-based reader. And regarding what I'm currently working on is that OSM PBF reader, also DataFrame reader, which I think it should probably land in, I think 2 weeks probably, but because mostly I'm occupied, I mean, I'm writing a book about Sedona, so that takes a lot of time. So I hopefully will be able to finish that soon. Also, regarding the geo package, I'm also planning to add predicate pushdowns based on the boxes which I mentioned previously. And maybe soon after another data frame-based readers for other commonly used geospatial data formats. And now the demo time. So I prepared a simple Jupyter notebook to show how you can load the geo package in Apache Sedona. So I put some geo package files on S3 bucket. I basically using S3 compatible Minio. And I have some input parameters to start my Sedona session. And now let's go how you can load the data from the S3 compatible Minio bucket. So I have two GeoPackage files, which is one is a vector, which is called Mazovia. It's the data from the OpenStreet format converted to the GeoPackage. And also I have some raster data, which is also stored on the S3 bucket. So first, what I've started is from loading the metadata for each of the file. So as you can see in this actually file, you have a table name. And then that table name you can then reference in your loader, because I'm starting from loading the metadata because I'm not super familiar with the file, which, for example, I get from another team in my company. So I'm looking, I have one table inside it, so I can then load it. And for the raster, I can see like there are 5 of them. So next, what you can do is to read, you pass the format geo package, and you pass the table name, which you can find here when you loaded the metadata. To load the metadata, you use that parameter show metadata in the option when you load the data. And to mention, you also, when you load the metadata, you also use the format geo package. Yeah, and going back to the vector data to loading itself, I'm passing the name of the file. I'm also passing the table name as a parameter and the name of that table. And as you can see, when I'm running this, it actually loads the data from the S3 bucket. You can see that it's converted to the special data frame. So, oh, typo. So you can see that the column type of the geometry is actually geometry, so the internal geometric representation. So you can apply which function you actually want on those. For example, you can select expression here and add some like function on this. So stgeom sts text, I think it's the name of the function, which is in Sedona, to convert to the WKT format. And for the raster data, like interface is the same. Basically, you need to say which table. In our case, I took that Aurora airport noise you can see here. And what's important now when I'm loading it, you can see that it creates, it has also like the data is styled. And what's more also, I think, important is the data type you can see underneath is the raster data type from Apache Sedona, as you can see here for the tile data. So you can apply any special, any raster special function to it by calling, for example, in here, rs summarize stats, and you pass that column name with the raster from the geo package, and you can calculate whatever you want based on that. Yeah, so that's everything, I think.
Cool. Really exciting features. Thank you, Pavel, for demonstrating that. Okay, so yeah, there's a question in the chat, Pavel.
Yeah, I can't see it.
Okay. It is in Q&A, not actual chat. It is in
Oh,
Q&A. Yeah.
okay. Yeah, you need to pass the table name in every like loading the data frame because basically geo package might have multiple tables with a different schema. So you cannot load it once at a time because Spark will be not able to merge the schemas properly.
Well, but what if we don't know the table name up front?
Yeah, right now, if you don't name the table name, you can look in the metadata table with all the tables and then pass the table name from the metadata. So there is no like default table which will be taken from the geo package. We might add that. I don't know if it's necessary. Yeah, maybe I'll share the screen again. And which exactly schema for which table for the metadata or
Yeah.
yeah.
Yeah, just curious, if you're exploring a kind of unknown geo package, maybe with really poor documentation, can you dump the schema, explore, even to the point of determining coordinate reference systems on the geometries?
Yeah, I mean you can look into that in the metadata table. As you can see, there is like
Oh, okay. Yeah, good.
description, let's change, identifier. I think CRS also is there, and I think it also like that CRS is then used to cast the geometry to basically in Sedona later.
Okay. Well, one question, kind of jumping back to like the KNN stuff, is that can you do coordinate systems as well as geographic systems?
Yeah, so the k-nearest neighbor joint query we have here, so it supports spherical edge. So you can supply like the distance it could use like meter-based distance, if that's
Okay,
what you mean. Yeah.
for
But it is not what's
you
that?
know for very extremely large area KNN applications. Okay, yeah, I get it.
Oh,
Thanks for the jump back.
yeah, no
Don't
worries.
mean to step on Pavel's presentation.
Oh, yeah. Anyway, I think it is the Q&A time for the office hour right now. So I see there is another question here. So, I have a couple of general question. Sorry. So yeah, I think there are a couple good questions here. So first of all, so right now we don't, although some of the old example notebooks still use RD API. So for us, we recommend you use SQL interface in Sedona because basically whatever function we have in RD have been supported our spatial SQL interface. So we recommend you guys use that. And on the other hand, so for the Python interface in Sedona, it is actually pretty good. So if you just use the regular Python interface to wrap around the SQL sentence, it is pretty good. So please feel free to use the Python interface. The only downside I see right now for the Python interface in Sedona is when you need to write a Python UDF. So that is the part, it is kind of slow, right? You need to go through multiple rounds of serialization back and forth between JVM and Python, right? So that is the part is kind of slow. But other than that, if you just use ST functions, that is totally fine. That is all happens inside Scala. Yeah, so you can always provide feedback on the Sedona book, right? So Sedona has a mailing list, Sedona has a Discord server, right? And also there is a GitHub issue. So you can like ping us there. You can find like Pavel, me out there in all these places, right? You can ping us there and provide feedback. And we always welcome feedback. Cool. So anyone, okay, another one has question. Does KN join expect data to be in the same CRS? Yes, right now it expect data to be in the same CRS. So if you have two tables to be used in the join, so both of them needs to be in the same CRS.
Oh, thank you, Chair.
So yeah. Yeah, feel free to ask questions. So if you raise your hand, I will like promote you to speak. So Victor has a question.
Yeah, I have a practical question. Currently, I'm using Sedona for some TIFF files to join it, but my original TIFF file is very big. It is like 50 by 60,000 pixels. So I'm now using Xarray first in the first process to cut it up into multiple tiles and then send it to Sedona. But what would be like a better approach for this?
That's a good question. So right now, if you use the Sedona raster function to load it, so there is a hard limit on how much data you can have per record. So that is, I believe, 2 GB per record. So right now there's no good way to do that at the moment. So in Variables DB, so which is a product we have at Variables, so it has a function called RDB raster. So that can actually bypass this. It can actually read data like it can automatically partition the big TIFF file to small tiles before loaded. But that requires the collaboration from a storage system, which is not available in open source Sedona. That's the downside.
Yeah, so the current approach is probably the best way for now to just cut it up before handing it over to Sedona.
Yes. If you if you use Sedona, like I'm curious. So where like are you using Sedona on Databricks or on EMR?
Yeah, on Databricks.
Yeah. Okay. Yeah. Yeah. So that's probably the best approach you can have right now on Databricks. Yes. Oh, folks, feel free to ask questions. Right. You can also raise your hand. I can promote you to talk. Oh, a few other things, right? As you can see from the slides I just shared. So Sedona is always calling for help. So Sedona is an open community. It has lots of people involved in the community, and we always need help from you guys. You can contribute back to the community by, of course, by just using it and provide feedback. And also you can contribute back by providing notebook examples and help others to understand what they can achieve through Sedona. And you can also help us update the documentation, right? So the documentation, honestly, it was mostly done by volunteers like us, right? So the documentation side is honestly not that good. So there are lots of small typos here and there, and probably some outlines are not clear. So also we are also wanting to have tutorials, very good tutorials. So all this help are really appreciated in the community. And also, we're also doing release test. So not sure if you're aware of, so Sedona has a mailing list. So you can subscribe to that. It is called dev@sedona.apache.org. Let me share it one more times here. I didn't paste it. So Sedona has a mailing list. So you can find some issues there. And before each release, we're gonna do a release vote in the mailing list. So we're gonna try to find out issues that potential issues in this release, and then we start a vote. So once everybody votes, then we make a release. So you can also help us with the release process, right? By testing the release candidates. And we also have a Discord server, as I mentioned before. You can find the link of the Discord server on that web page, on Sedona web page, and you can join that and ask questions. So Sedona PMC members and committers are very active on those in those places. Feel free to reach out. All right, folks. Do you guys have any last minute question? Any question? Using okay. First question. Okay, so the first question is related to the hotspot analysis is taking forever. So let me James is here actually. So James Willis is the contributor of that function. So James, you want to talk about that?
This question about delta?
Yes, saving result in delta, saving the getting order result in delta. I suspect that is probably related to the partitioning because the result was not fully materialized when you do the show. So it is fast, but when you try to save it to the delta lake table, it try to materialize the entire table.
Yeah.
So that actually takes time.
I wonder also if, let me think. Because there's this distinct, because this is through the function. This isn't, the SQL's not out yet.
Yes.
Yeah, I don't know. I mean, it returns like 6 columns. So I suppose you could project away some of the columns and potentially save yourself some time. I don't think there's anything about like get a sword inherently that makes it take a long time to write to delta.
Yeah. So one thing you could try probably is you could try to save it to GeoParquet and see if the issue still persist, right? If the issue still exists, then that's probably a problem in our hotspot analysis function, right? If not, it is probably an issue to Delta Lake. Okay. All right. So there's another question there. So is there any update on Apache SIS migration? So this is a really good question. So like let me provide a little bit context around this question. So Sedona raster functions and the Sedona CRS transformation function. So they rely on library called GeoTools. So GeoTools, first of all, it has like the CRS transformation and raster function in GeoTools are not well maintained. So many code actually has a bug and has some performance issue. So we wanted to migrate that to another library called Apache SIS. So which is also an Apache project. Another good thing about Apache SIS is it is using Apache 2.0 license. That means we can natively we can package SIS into Sedona. And the GeoTools is not using the Apache 2.0 license, meaning that the license they use is not compatible with Apache 2.0, meaning that we cannot actually package GeoTools into Sedona. That is also the reason why right now, if you use Sedona, you always have this separate jar called GeoTools jar to load. So that is because of this copyright issue. So, but in order to migrate to Apache SIS, so it requires a couple of things. So the most important thing, long story short, the most important thing is we must migrate Sedona to support Java 11. So right now, Sedona support Java 11, right? But it is compiled against Java 8. However, Apache SIS only support Java 11. So if we support Apache SIS now, That means Sedona is no longer compatible with Java 8. So that is the problem. So based on the statistics we obtained last year, so we tried to do this last year, like the jobs support for Java 8. We tried to do that, but based on statistics we obtained last year, it looks like the vast majority of the users are still using Java 8, which is super sad. But based on the statistics we obtained recently, so it looks like people are shifting towards Java 11 or higher version of Java. So that means we will likely do that in Sedona 1.8. So which is around I would say around March or April this year. March or April this year. So we in that release Sedona 1.8, we're gonna start to support job support for Java 8 and start to migrate to Apache SAS. And that's gonna provide us with better CSS transformation accuracy and better function around raster data processing.
Thank you, Gio.
Okay, there are another question. So on Databricks, is it on Photon or not Photon? Yeah, that's probably another thing, right? So right now our support on Photon is kind of not that stable, right? Uh, so try both option. So I suppose the non-Photon one should work. Oh, all right. So I think we can stop here. And thanks everybody for attending the office hour. And the recording of this office hour and the slides will be made available through YouTube videos, and we're also going to paste it to our Discord channel, and you can review it at a later date. And very happy to see you here, and looking forward to see you next month. All right, thank you guys. Bye.